Alright, here we are again. Part 2. Might be 3, but the next part. Alright, we're going to discover an aspect of light that is somewhat questionable, and that is the fact that we have been boasting that light is a wave. So we're going to pretend that it is a wave for today. Tomorrow we might alter that. So a little warning. Light is a wave. So I'll put a little question mark there, but you can't see that question mark, right? Light is a wave. So we learned it was a transverse wave, like the slinky that I oscillated up and down. And we are going to look at some characteristics of light being a wave and see if we believe it or not. So what should we do first? Here's how waves act, and let's discuss whether light does that. Say we have a slit. What do you need? Say we have a barrier here, and there's a slit in the barrier, and we are emitting light toward it. The light is coming toward it in a transverse wave, like this, and we'll have a whole band of crests coming toward it. And they're going to be a lot smaller than the wave I drew. So here comes a band of light waves. What I'm drawing are the crests, and they're headed toward this barrier. And let me change colors on the barrier. So here's the barrier, and there's a slit, an opening in the barrier. Zach, by the way, when we calculated the velocity of sound at 15 degrees, we got 341.
Okay.
So times 1, that is 341 meters, is about a fifth of a mile.
Dang,
So
should have said 4.
we have to count to 5. See the flash, hear the thunder, and every set of 5 is 1 mile.
Got it. Okay.
Right.
Sounds good.
Alright, now we're talking about light acting as a wave. There's a little question mark there, but you can't see it. So that's just a forewarning that today I'm going to teach light as a wave. Tomorrow it's going to change. So here we have light coming toward a barrier, and there's one slit in the barrier. If light is a wave, it will diffract. That means it will bend. Diffraction is just a fancy word for bending. So draw a picture of these crests. These are all crests, lights, crests and troughs, crests and troughs. So I have all these crests headed toward a barrier with an opening in it. When it hits it, it will diffract. When it does that, it bends. If light is a wave, it will do this. So it'll continue to crest, but it'll be in this bent pattern. Now, look what happens when we hit a second barrier. This time, the barrier has 2 slits in it. Then things get really exciting. So let me erase the word bending so you can see. All right. I'll move this down. Diffraction. This is diffraction when it bends like that. So, what happens when diffracted, bent light hits 2 more barriers? Probably it's not hard to imagine, but this is going to diffract through here, and this is going to diffract through here. Alright, so we're going to have 2 of these diffracted areas meeting. The important part, the interesting part happens when here we have a crest meeting a crest. So right there, when we have the double refraction, diffractions, we have a crest meeting a crest, because each of these solid lines are representing a crest. Then in here, we have a trough meeting a trough. So the bottom parts are meeting a bottom part. Trough meets trough.
Wait, hold on.
So
It
we're
like
gonna,
literally blinked and the whole board was like.
so we have two waves that are going to intersect each other. Crests from this slit are going to intersect crests from that slit, and they're going to intersect, causing supercrests. That's my name. It's not a technical name. We're going to have a double crest. So if the wave was going this high, it'll double the crest. So these are higher crests, these are lower troughs, but in between, somewhere in this mess, and I can't even point to it, but I know it's there, there's going to be a half of a crest meeting half of a trough. What will it look like there? It'll actually cancel each other out, and there'd be no activity at all. So somewhere that's going to happen. Maybe in between these two. So that's the part I'm kind of interested in today, where half of a crest will meet half of a trough. And there will be this canceling effect. There will be no wave at all. So this will create crest meets crest, the crest doubles up here. And here trough meets trough, so the trough doubles. It'll be twice as low. But here, when the half of a crest meets half of a trough, there's cancels the wave. There's no wave at all. So I'd like to kind of demonstrate that with water, and I tried it at home and it didn't work. So I found a video that has a few second clip that'll show you what I mean. So do you need this? Should be in your sketch, so I'll take a minute. You need to realize we're going to look where two wave patterns intersect. That's called interference. This is all this stuff where wave meets wave is called interference. And when a crest meets a crest, it's constructive interference. And where a half a crest, I think a trough meets a trough is destructive interference, but don't quote me on that. It only took me 40 times to get this down.
You gotta pull it out once you get to the
You want to try it, Zach?
I kind of thought it was in your eyes.
I tried it 40 times this morning. So, yeah, at least. Got my arm worked out, so that's all right.
I thought she did.
Oh, I didn't watch what you did.
You just, when you get to the bottom, pull it out.
Oh, when you get to the bottom, pull it out. Not as you're pulling it.
No, yes, when you get to the bottom, just pull it out.
All right, everyone tells me a different trick.
That one has yet to fail.
Okay.
Except for that one board that we did have, but that was because it was broken, not because the technique didn't work.
MD, could you get the remote there on the table and hit blank? It'll open it up for us.
Wait, do they have universities? They've already got the picture. Like,
Turn the light off?
Hopefully,
What is that?
Yeah.
Ready for the light?
We might watch this, but
There's a bright spot underneath, so we would see two bright spots on the bottom of the box.
no, but you're
But if
supposed to
what
do
he's
that.
thinking is waves, then the waves
Okay.
are slip.
all right, what we're gonna see here is he's just gonna do the same thing that I did with light on the board. He's gonna do that with water. So if you would give him your attention.
Can interact with the waves from the other slip. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern.
That's what I was trying. Do you see those blank spots right there?
Yeah.
That's what I tried to do last night at home.
where they
Where?
meet up peaks with
I was
peaks
in
and
the
troughs and
sink.
troughs.
Wait,
Whoa,
that looks so cool.
Constructive
Can we do that?
That's like a
Can we
stadium.
go on a field trip? Yeah.
Meets up
It's
with
in
a
the
trough
stadiums.
for
The
the
stadiums
other.
are set up.
Then
We
get
should try it,
destructive
Pat.
interference.
Can we
and
do that?
basically a wave there.
Let's go to M. Keen's pool.
Really good.
When the light from
Is it
one
open?
slit met up, peaks
too
and
cold.
peaks and troughs of troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
This is basically the same as like having 2 drops of water fall into
Okay, so we might watch that whole thing after we talk about it another time. But I wanted you to see what I meant anyway, so I'll hold on to this for a second.
Yeah.
Where's the... Alright. Does that give a little more meaning of what I was trying to draw on the board?
I-
Okay, that's cool. I went to my sync last night.